Well, hello guys, Mr. G here, and this is going to be another video for the grade 10s learners. This time we're going to be talking about transverse waves. In the previous videos, we spoke about pulses, we spoke about interference and superposition. So we learned that a pulse is a single disturbance in a medium, and a medium is any substance in which a pulse can propagate. Then we learned about superposition, that is when two disturbances meet at a point, then you will get a resultant disturbance. If the resultant disturbance is bigger than the two previously one, then it's going to be called constructive interference. But if it's smaller, then it's going to be called destructive interference, and you also saw a video with the demonstration. Now here we are going to be speaking about transverse wave. Now, what is a wave? A wave is a periodic continuous disturbance that consists of a train of pulses. So it's going to be many pulses without stopping. So we said a wave is a periodic continuous disturbance that consists of a train of pulses. So in other words, a wave is a train of pulses, okay? So, for example, this one here can represent a wave, okay? Now, we have two types of wave. Wave can be divided into transverse wave and can also be longitudinal wave. So, these are the two types of wave. It could be a transverse wave or longitudinal. There are other classification of wave. Now this one is having in mind how the particles of the wave move related to the motion of the wave. Okay, so we are going to classify the wave according to that one in transverse wave and longitudinal wave. And now, only now, for now, we are going to be focusing on transverse wave. We are going to be looking at transverse wave. So, what is a transverse wave? A transverse wave is a wave where the movement of the particles of the medium is perpendicular to the direction of propagation of the wave, the same as we did when we define pulses. So, let's say we have a transverse wave. For example, this drawing represents a transverse wave, and obvious, the transverse wave is made up of particles. We did previously the same with pulses. So let's draw some particles in this or on this transverse wave. So those dots represent some particles on the wave. Now, how are those particles going to be moving? Well, in one side of the wave, they are going to move in that direction. They are going to be moving in that direction, for example. All right, these particles move in that direction as they come in there, but these ones were moving down. That is why the wave is going in that wave, and so on. This side particles moving up, and this side particles moving down. Okay, so this is what happened. However, the wave is propagating or moving in that direction. That is important. You can see that the motion of the particle is up and down, is at right angle. However, the propagation of the wave is straight to the right or left or any other direction. So you can see that the particles are at right angle to the motion of the wave. So we're going to say that this here is the motion of the wave, and this one here is the motion of particles. Okay, and you can see that they are at right angle. Now, there are other important things we have to learn on some definitions. We have in a wave all here peaks. All this one here is a peak, for instance. This one here, this one here, and this one here. All these ones there, all these peaks are going to be called crest. All those sides there are going to be called crest. So the sides top, the higher side of the wave, are going to be called crest, and the sides at the bottom, these lower points here, are going to be called trough. Okay, so all those top there are going to be called crest, and all these ones here at the bottom are going to be called trough. right? So that is very important. So we have the points top, the highest points that are going to be called crest, and the ones down are going to be called troughs. Now, what is important to know so far? The transverse wave is a wave where the particles move at the right angle to the propagation of the wave. Second, all the highest points on top of the wave are going to be called crest, and all the points at the bottom, the lowest point, are going to be called a trough. Okay, so this is the important things yet. Now let's go to another clean drawing real fast. Okay, so let's look at this new drawing brand new. So what we have here, we have a transverse wave. We have this blue line represent the motion of the wave, but that point which is in between, right in the center of the wave, is also the position of rest of the particles. So at that point, the particles are at equilibrium, or is at rest. What does it mean? If there was no disturbance, the particles would be at that specific point, all right? So we have crest on top, the highest point, we have troughs at the bottom, the lowest point. Now, what else is very important here is the amplitude. And as we did with the pulses, the amplitude is the maximum displacement of the particle from its equilibrium or rest position. In other words, the amplitude is the distance that is going from this point here to this point there. Or the same will be this point here to that point there. That is what we call amplitude. Alright? That is the amplitude. Important to know. So sometimes they give you the distance from here to here. Now this one here is 2 times the amplitude. Alright, so important to notice. I am going to take it out, not to just make you perhaps confused, but note, because most of the time they're going to give you that one. So the amplitude is the maximum displacement of a particle from its equilibrium position. The amplitude is the maximum displacement of a particle from its equilibrium position. Okay? And guys, for this video, we're going to stop right here. That is going to be the last part of this short video. First of all, a definition of a wave. We learn about the definition of a wave. Second, we classify wave as transverse or longitudinal. We focus on the transverse. A transverse wave is when the particles move perpendicular to the propagation of the wave. Then we learn about the crest and the trough and about amplitude. So this video is going to stop here. Next time we're going to be speaking about wavelength and some other definition like period, frequency, etc. Thank you for watching. Subscribe for the channel. Thumb up. I'll see you next time.